Hi, it's Mr. Kane here, and we're going to talk about how we know about what's inside the Earth. Because we haven't really been to the middle yet. We've been some of the way. So how do we know what's down there? So we've got clues from things like mining, volcanoes, earthquakes, tectonic plates and how they move, and the magnetic field. They all give us clues about what's inside the Earth. Let's find out more. So mining and drilling holes for oil and stuff, we've gone down a few kilometres, and they tell us that it gets hotter as we go deeper. They also tell us about the layers of rock that we've gone through. So they give us a little picture of just a few places where we've poked into the ground. Volcanoes bring up molten rock from deep under the earth in the layer that we call the mantle, and that gives us tells us it must be hot down there because there's molten rock coming out, and also what the rock's made of. The chemicals tell us about some stuff down there as well. Earthquakes are really good at helping us out with this. They're like sending shock waves through the planet, a bit like sonar, how a submarine finds its way around, or radar letting us know where airplanes are in the sky. This is what earthquake waves are doing for us as well. We've got different kinds of earthquake waves. We've got the P wave, or pulse pressure wave, the S wave, the shaking wave, and these surface waves as well. But we'll look at the P and S wave because they tell us quite a bit. So P waves will travel through anything, but where they go from a solid into a liquid, they get refracted, and this creates a shadow zone where earthquake happens here. Seismographs all around the planet will pick it up, apart from the ones in this zone and this zone here. S waves travel through only solids. So where there's the liquid in the middle of the planet here, it creates this shadow zone. Seismographs don't pick up the S waves here, but they do here. So we now know the size of a liquid core inside our planet. We can map out where the volcanoes are. Look at the Pacific Ring of Fire. That tells us something there. Because if we overlay a map of earthquakes, look at the similarity. If we scroll back, there's the volcano map, there's the earthquake map. Look at how similar they are. And then when we go to the map of tectonic plates, okay, so that's got some volcanoes marked on it, and all those black lines are the edges of the plates. Look at where the earthquakes happen. Look at where the plate boundaries are. And look at where we are here. So this is all telling us about what's happening inside the Earth. How do those plates move around? Well, we now know a very hot liquid inside of the planet down here. Lots of heat coming up off that, lots of heat coming up. So that heats the mantle layer, creating currents in it because the hot rock rises up. And as it hits the top here, it can't go through the solid. Some places it can where there's a volcano and it erupts out, but mostly it moves along the base of the mantle very slowly. The mantle moves on the base of the crust, and as it does that, the friction drags the plate with it. The slab pull, it gets pulled along. So that's what's making the tectonic plates move. We've also got, as the plate descends down here, getting forced down, the weight of it pulling it down also helps pull it along a bit. But it's the friction between the mantle rubbing beneath the crust here, creating the slab pull that does most of it. We've also got this magnetic field. We know we have a very hot molten inner core. We suspect that it's mostly iron because it's a very heavy element, and it's very common in our crust and common in the mantle. And if it's molten and it's heavy, it must go down to the middle here. In the center, the pressure, we believe, keeps it solid. We know that it's liquid here. Now we've got this magnetic field around the Earth, and that's created because this liquid core here the liquid core is spinning around, it's revolving around, and as it does that, it generates a magnetic field, which we find very useful to figure out where we're going with compasses when we're hiking or navigating with ships out in the ocean. So all those clues put together allow us to build up a picture of what's inside the Earth. Where the layer boundaries are, the earthquake waves tell us that. Because they don't travel through some parts of it, we figure that it must be liquid. It's got to be pretty hot. We're theorizing that it's iron, and we're theorizing that the center for the pressure must be solid. But the other layer boundaries and what's down there, we've seen what comes out of volcanoes, and we've seen the picture that earthquakes give us. So that's how we know about what's inside the Earth. I hope that's been helpful.